In this video, we're going to go through the practice questions for angles, the Pythagorean theorem, and similar triangles. Question number 1 says, in the figure below, angle ACD measures 112 degrees. So let's label that 112. Angle BAC measures 40. And points B, C, and D are collinear. What is the measure of angle ABC? And so we're looking for this angle right here. When we're told that points B, C, and D are collinear, that just means these 3 points are on a line. They lie on the same line. We're looking for angle X, which is a part of a triangle, and we know that the 3 angles of a triangle will add up to 180 degrees. If we can get 2 of the 3, we can find the third. We already have 1, this 40-degree angle. We're looking for X. If we had this angle measure, that would help us to then be able to add up to 180. Well, we know that the angle that is supplementary to angle BCA is 112. And so this is a supplementary relationship right here, 2 angles that add up to 180 that form a line. So we have this angle BCA plus 112 is equal to 180. So that gives us that angle BCA is equal to 180 minus 112, which is 68 degrees. So that gives us an angle measure of 68 right here. And now we could take the 3 angle measures, 68 plus 40 plus X. Those 3 should add up to 180. And we can find X by subtracting 68 and 40 from 180. And we get that X is equal to 72 degrees, which is answer choice B. Now looking at question number 2, it says, in the figure shown, the measure of angle CAD, so we're talking about this angle measure here, is equal to 6x plus 10. And the measure of BAD is 90 degrees. It's labeled here with a 90 degree. What is the measure of angle BAC? So we're looking for this angle. Well, this now is a complementary angle relationship. We know that these 2 angles, angle BAC plus angle CAD, add up to 90 degrees. And we know that angle CAD is equal to 6x plus 10. And don't let this 6x, the x, the variable in there, bother you, because notice in the answer choices we have the variable x. So that's okay. So we're looking for angle BAC, and we add that. Now we've plugged that in. Now we can find that angle BAC is going to be equal to 90 minus 6x minus 10. We distributed the negative sign, and we have 80 minus 6x for angle BAC, and that is answer choice H. Question number 3 says, for triangle ABC, which of the following is an expression for x in terms of y? So we're looking for an expression for x in terms of y. If you'll look at your answer choices, what that means, our answer that we're looking for is going to have a y in it. All of these are equal to x equals something. That's what we're looking for here. When we have a right triangle, which we're given here at angle A, we can make use of the Pythagorean theorem when we are talking about side lengths. So we're going to make use of that, which is a squared plus b squared equals c squared. We're going to remember that because now we can write out this relationship. These are our 2 side lengths, x and y, and then we have our hypotenuse, the 12, which is c. So let's rewrite this as x squared plus y squared equals 12 squared, which is 144, which is 12 squared. Now we want to solve for x. So I have x squared equals 144. We're going to subtract the y squared. And then I'm going to take the square root of both sides. And when I do that, I have x is just equal to the square root of 144 minus y squared. I cannot simplify that. I can't pull anything out. And that is what answer choice D is. Question number 4 says, what is the length in inches of the hypotenuse of a right triangle with legs that are 7 feet and 10 feet respectively? So we have a right triangle. We're given that by definition. A right triangle that has leg lengths of 7 and 10, and we're looking for our unknown hypotenuse. We're going to make use of that Pythagorean theorem again. A squared plus b squared equals c squared, and we're just going to plug in the values that we're using. 7 squared plus 10 squared equals x squared, so that's 49 plus 100 equals x squared, so that's 149 equals x squared, and we'll take the square root of both sides, and we get that x is equal to the square root of 149. We cannot simplify that anymore. That is our exact answer. Answer choice H. Now we'll look at question number 5. It says, in the right triangle ABC below, DE, we're talking about right here, is parallel to AC, we have that length right here, and DE is perpendicular to CB at E. And perpendicular relationship here is going to give us this 90-degree angle. The length of AB is 26. They have labeled that. And the length of DE is 5. They have that here. And the length of BE is 12. What is the length in units of AC? So we're looking for our unknown X. So when I'm looking at this, it's almost like we have a triangle built into another triangle. And with our angles being the same, we have two 90-degree angles. The measure of angle DBE is the same in both the triangle ABC and DBE. So we have this angle that is the same. So these two triangles, the larger triangle of ABC is going to be similar to the smaller triangle of DBE. And we're actually looking for this unknown X. We know that both of these are 90. These are both the same angle measures there. So we can look at some things here. We know this is an angle measure of 12, and this is 5. And we also know that this full length is 26. As we looked at previously with Pythagorean Theorem, if we can figure out some of the side lengths, we can make use of the Pythagorean Theorem. We don't know this side length here, CB, so that's not going to help us for the larger triangle, but we do have two side lengths on the smaller triangle. We could find this third length and maybe use a proportion since they are similar to help us find that. That is one method that we could use. When we look at our side lengths for this smaller triangle of 5 and 12, something should kind of be familiar here. We have a Pythagorean triple, and that Pythagorean triple is 5, 12, 13. So this measure is 13. If that did not immediately come to you, you could have always done the Pythagorean theorem of 5 squared plus 12 squared is 144. That gives you 169. That would be equal to if we call this the y, the hypotenuse squared, y is equal to the square root of 169, which is 13. That's our 5, 12, 13. This is the one that goes right here. 5, 12, 13. Because these are similar triangles, now we can set up proportions. We're looking for this length, which is in proportion. Here we have, it's similar to this side length, I should say. So we have x over 5, the larger triangle over the smaller triangle's side length. Now we can make use of this hypotenuse, the hypotenuse of the longer triangle of 26 over the hypotenuse of the smaller triangle we just found to 13. This is a proportion. We can do this because these triangles are similar. So we can cross multiply now, and we have 13x is equal to 26 times 5, which is 130. Divide through by 13, and we get x is equal to 10. And that is answer choice A. That's our length of this larger triangle that we're looking for.